All right, so Algebra 2. And I need someone to pass out the cards as well. That one was closer, sorry. We are on lesson 7-1. We are on a brand new unit. That means unit guides have already been distributed on Google Classroom. Let's take a quick peek at Google Classroom, or not Google Classroom, but our unit guide. This is for geometry. Where is Algebra 2? There's Algebra 2. Here is our guide. We have 7 lessons, 2 quizzes, 1 test. So it's a much shorter unit than Unit 6. This was Unit 6 back here where it was super long, and I don't know what that's doing down there. Thank you. So here's our nice and short unit, and it's going to go quick. So it's a total of 10 days because 7 plus 2 plus 1. So there's a total of 10 days or 2 weeks. We will be done with Unit 7 in 2 weeks. Any questions about Unit 7? We see what we're doing? We see that we have 2 homework assignments tonight.
Oh my gosh.
The first one is medium, the second one is hard. This rewrite exponential expressions, it is pretty difficult. Cool. Yeah. So, let's review basic rules of exponents that you learned in, I don't know, 8th grade, reviewed also in Algebra 1. Now we're reviewing it again in Algebra 2. Anything. X represents anything to the power of 0 is, quiet, raised hand. Quiet, raised hand. Quiet, raised hand. Fiona. 1. Write it down. You need to know anything to the power of 0 is 1. Coming back here. Fiona. Got some XP. Okay, x to the power of negative n is what? How do I rewrite that with a positive exponent? Fiona's ready again. Who else is ready? How do I rewrite this with a positive exponent? I'm sure I could talk to Sergio and he would be able to tell me because he's in Algebra 1 and knows this really well, right, Sergio? X to the power of negative n is 1 over x to the power of, Sergio? 1 over x to the power of n. Thank you, Gio. And vice versa. There's a secondary rule, so I'm going to do an arrow over here. There's a second rule. You should be writing this down, right, Chris? Right, Chris? You're writing these down? Yeah. The second rule is that if I have 1 over x to the power of negative n, that can be rewritten as what? Quiet raised hand. Oh, Sergio does know this one. Okay. Go for it, Sergio. XN? Yeah, x to the power of n. It's cool because we just did this lesson like 2 weeks ago in Algebra 1.
You still remember?
And he just took his test today. All right. Thank you, Sergio. XP. I'll find you later. All right. Someone else do this one. X to the power of n times x to the power of m. If I have similar bases, what do I do with the powers? Sergio's trying to help you guys. If you just look over there. James, go for it.
X to the power n plus m.
There it is. N plus m. Write it down. James has it.
This is going to be the lesson?
No, this is a review. This should nothing here should be hard.
I did this?
Yes.
That was 2 years ago. I don't remember what I did yesterday.
Nothing here should be hard, and if it is hard, I'm worried because this stuff is difficult. All right. Coming down here. Let's do an example. Let's come back here and do some examples. We should have been doing an example anyway. You have to do an example that is similar to Mr. Sindel's, but you can't copy my example. That's cheating. 171 to the power of 0 is 1. There's one example. You need one example. Here's another one. Negative 73 with parentheses equals, if that's to the power of 0, equals 1. If I did not have parentheses, it would have been negative 1. Do your own example for x to the power of negative n. If I have something like 7 to the power of negative 1, that's equal to 1 over 7. If I have 2/3 to the power of negative 2, that's going to be 3 over 2 to the power of 2. Do your own examples. Your own examples. And finally, your own example for this other one. We have x to the power of 2 times x to the power of 3 is equal to x to the power of 5. That's an easy one. Let's do a harder example. 5 to the power of 2 times 25 to the power of 2 is equal to 5 to the power of 6. Ooh, that was a tricky one. I bet Sergio might not have even known that one. By the way, this second example is the level that we're at today. You need to be able to understand this example for today.
I don't know how to do that.
Don't know how to do it? Well, 25 to the power of 2 coming off here to the side. 25 to the power of 2 is the same thing as 5 squared. 5 squared is 25, right? Squared. So 25 squared. And then when I have exponents, we're about to learn that rule right here, but we'll see it later. Let's actually jump down to that rule. If I have a power to the power, 2 to the power of 2, that's equal to what? X to the power of... Good guess. Not n plus m. nm. N times m. N times m. Which means I multiply 2 times 2 on my example up here. 2 times 2 is 4. This is 5 to the power of 4. Therefore, this one could have been 5 to the power of 4. So 5 to the power of 2 times 5 to the power of 4. I add the exponents, 2 plus 4, and I got 6. Hopefully you're at least at a 2 out of 5 for the fist of 5, understanding that example over here on the right. Let's do an example for this one. If I have, I don't know, 2 to the power of 3, all of that to the power of negative 4, that is equal to 2 to the power of negative 12. Make your own examples. They cannot be copied from Mr. Sandell's. Make your own example, just using this property over here on the left. All right, very similar to property number 3 here with multiplication. I now have division. X to the power of n divided by x to the power of m. Notice it's the same number. Let's make this note. This x and this x are the same number. These are the same number. It's not 2 and 3, it's 2 and 2, or 3 and 3. So, when I multiply with the same bases, I add the powers. When I divide with the same bases, I do what with the powers? Quiet, raised hand. Is there anyone out there with a card, Geo?
You subtract the powers.
Yep, so x to the power of?
N minus m.
There it is. All right, your card is now in, Geo. Thank you, thank you. And do 1 or 2 examples. So I can do x to the power of 7 divided by x to the power of negative 1. Ooh, I'm starting to include negatives here. That's going to be x to the power of 8. Because I'm going to do 7 minus negative 1. It's really 7 plus 1. 7 plus 1 is 8. Coming down here to my next rule, x times y, all of that to the power of n. These two, let's go ahead and put this little parenthesis on both of them. These two are really distributing. Let's write the word distribute. Distribute. I'm going to distribute using the same rules. I'm having a power, so this power is going to go to both of them. And this is going to be what? Quiet raised hand. Gio's ready. Someone that has their card still? Take a guess. Fiona? There it is, times y to the n. The main trick here is you can go forwards and backwards. You can distribute, which means you can factor. The opposite of distribute is to factor out. So this is both directions. Go ahead and draw arrows on both of these. You can go both directions. Put arrows to let yourself know you can go forwards or backwards with that property. Technically, all these properties you can go forwards and backwards, but I feel like this property that I just talked about is frequently forgot where you can go backwards. Most people think you can only go forwards. So give yourself one example. So something like 3 times 2, all of that to the power of 4 is equal to 3 to the power of 4 times 2 to the power of 4. Again, do not copy my example. Change your own numbers. Make your own example. I'm okay with you just tweaking the numbers. It's even better if you come up with your brand new example. We have 2 more properties to review before we start learning new stuff. I have this other distributive property. Who wants to take a guess at it? Someone that still has their card. So Fiona has her card turned in. Gio has his card turned in. I'm looking at these 3 ladies over here. the Stephanies, Team Stephanie, Andrea. Chris has fallen asleep. Come on, someone new. Distribute that n. Leave it as a fraction. Distribute the n. Go for it, Teflon.
Xn over 1.
There it is. X to the power of n over y to the power of n. Teflon is in. Thank you, thank you. Let go. All right. Give yourself your own example. For example, 1/2 to the power of 3 is equal to 1 over 2 to the 3, or 1 to the 3 over 2 to the 3, which is equal to 1 over 8. There's a cool little example. And this is one that you can just rewrite it in terms of a radical. You won't be using this property today for the homework, but it is something I'm going to give it to you. That way I can say that I showed you some review. If I ever need this for another lesson, I will review this property. I'm not expecting you to remember it for the rest of the unit. This one can be rewritten as a square root. Anyone want to take a guess at this one? This one's really hard. I'm going to have to give it to Jessica because she knows it. X to the power of n over m can be rewritten as a radical. You remember this one, Jessica? You're really close, but not quite. It has a square root in it, a square root symbol. This symbol, by the way, for all of us, is called a radical symbol. So I can sometimes read this as radical x to the power of n. What is the index of this radical? Someone from Algebra 1 or Algebra 2? Sergio. M. The index here is m. This is the mth root of x to the power of n. But that can be rewritten also as the mth root of x, all of that in parentheses to the power of n. There are 3 equivalent forms. So you can give yourself your own example. One example that I have is x to the power of 1/7 is equal to the 7th root of x. Technically x to the power of 1, but still. All right, that was a quick rundown of our properties. If I go to Camtasia, will it tell me how long I've been recording? Nope. Don't know how long it took us to do that, but there they are. You will be needing, if you want to remember 2 that you really, really need for the homework, it's these 2 right here. These 2 are going to be used more than any other of the other properties. Let's go to an example 1. Example 1 and 2 I would consider to be medium level problems. They relate to the first homework problem or first homework assignment that you'll have. Example 3, 4, and 5 refer to the third homework assignment. I consider that to be a hard homework assignment. Second homework assignment. You have 2 homework assignments. 3, 4, and 5 are the second. 1 and 2 are the first. That came out wrong. All right. So you are either going to be checking equivalent or not equivalent. That is how the game works. So I need to rewrite this in another form. I'm going to be using this third property, x to the n times x to the m, this property right here. How can I use that property to rewrite my expression that they give us? Andrea.
Wait, no.
Wait, what? Can you repeat that question?
Rewrite this expression into something that's 4 to the power of something.
Gotcha.
You got me, Gio? Let's do it.
It's a 4m.
4m. Is that it?
No, like 4 to the power of 4m.
4 to the power of 4m. Yes, you're correct. Because you add m plus 3m. m plus 3m is 4m, so Gio gets his points. This comes from that property where you just add m, add 3m, and then leave the base. Don't touch the base. Question, Fiona?
Yes.
How do you stretch correctly?
Why is it 4m and not 16? Or, I mean, 4 to the power of 4m and not 16.
Yeah, so it's coming back to this rule. Notice that this x and this x and this x are all the same. I didn't say x squared n plus m. The base is not touched. Same base, same base, same base.
Oh,
Yeah, that's a great question. I'm going to give you XP because it's a good question. All right, so is 4 to the power of 4m equivalent? Yes or no?
Yeah.
Thumbs up, good. It is, because it's literally 4 to the power of 4m. What about 16 to the 2m? What are we thinking? No. Let me see thumbs up, thumbs down. What do you guys think? The answer is yes. I'll show you why. What? In my classroom? In my classroom? All right. So 16 is a square number. What squared is 16? So I can rewrite 16 as 4 squared. Can we all agree that that is 16?
Yes.
So this is 16. This stuff in the parentheses is 16. I'm going to rewrite the other stuff, 2m. So far, so good?
Yes.
I have rewritten 16 to the power of 2m right here. Now, I'm going to use another property. This property right here. It states that if I have a power to the power, I multiply the powers. Oops. So I multiply the powers. I'm going to multiply 2 times 2m. Leave the base. Notice that the base is the same here and here. Don't touch the base. The base is 4. 2 times 2m is 4m. This one is equivalent. Write it down. Write this down in your notes. 4 to the power of 2 to the power of 2m. All right. And finally, 2 to the power of 8m. I'm going to give you 10 seconds to think about it, and then you're going to vote thumbs up or thumbs down. 5, 4, 3, 2, 1, and vote. Thumbs up, thumbs down. Is it equivalent? Thumbs up. Not equivalent? Thumbs down. James, talk to me. You were the only one that put your thumb up. No? Okay. The answer is yes. I'll show you why. The answer is yes, because 4 is also a perfect square. 4 can be, this thing right here, 4 can be rewritten as what? 4 is 2 to the power of 2. I have just rewritten 4. I've just rewritten this 4. This 4 is to the power of 4m. This 4 is to the power of 4m. Again, the same property. I multiply the exponents. Don't touch the base. The base is still 2. 2 times 4m is now 8m. These are all equivalent forms. Now I feel bad for saying that this was a medium difficulty assignment.
I don't even get what we did.
You're rewriting all of these using these rules of exponents. We have to become masters of the rules of exponents by the end of this unit. Hopefully by the end of today, we'll see. All right, so again, I'm doing the same thing, applying the rules to this expression, 25 to the power of half t squared plus 2t. Are they equivalent? Are they not equivalent? I need to rewrite this term. When I multiply, darn it, I can't multiply. I can't multiply because I can only multiply when I have an x and when I have an x. What I have down here is an x and a y. They're not the same. But is there a way to maybe make them the same?
No, let's not do that. No.
How do I make them the same, Fiona? It's a good idea, but you can't actually do that. You can rewrite 25, though. 25 can be rewritten as what? 5 squared, yeah. So this is 25. Now read the rest of the expression for me, Fiona. It's 5 squared, and then you have to do this exponent. 0.5t squared. And that's now still being multiplied by 5t. All right, thank you, Fiona. You have rewritten a form. It's going to help us. It's not quite the answer. Now I'm going to use another property. Another property. Now that I do have the same base, I need to somehow get all of this as one expression, one number. I guess it's technically a term. How do I combine 2 and 0.5t squared? What do those two turn into? Gio's saying multiply. What do they multiply to, Gio? What's half times 2 times t squared? What's half of 2? 1 what?
T
There it is, 1t squared. This is just t squared. So now I have the expression.
Can I go home now?
Now I have the expression 5t squared times 5t. What do I do with the exponents when I have the same base?
Add the exponents.
You add the exponents. So this guy's final resting form, we can't do anything else to it, is 5t squared plus t.
So 5.
5t squared plus t. I can make my t's slightly curvy, and I can do this in a different color. This is going to be 5t, t like that, squared plus t. Notice that this is written with a base of 5. This is written with a base of 25. Is it possible to rewrite this number with a different base?
Yes.
How?
Just say it over here.
I just did it over there. It's the same thing. So walk me through it, Andrea. This 25 can be rewritten as 5 squared. And then read me the rest of it. You just did this part.
0.5t squared.
0.5 t squared
And then you
plus
multiply-
2t. And I should be careful about how I write my t's and pluses. So this is a t squared plus 2t. Okay, then what do you do? So put parentheses around this guy if you want. I'm going to multiply something.
Yeah, multiply t squared. Wait, no. 2 and 0.5, which is what you distribute.
You distribute, yeah, because they're two different terms. So I distribute and you get
T squared plus
5 to the power of t squared plus
no 14.
4t. I'm going to pause right here and let you guys ask questions. Ask me as many questions as you can,
Why would I hurt my brain a little?
because you need to be masters of rules of exponents.
Wait, why did you do that separate problem?
This separate problem up here, because this one was written in base 5, but this one was written in base 25. I wanted to see if maybe if I change this to a base of 5, if it comes out to be the same answer. So this was 5t squared plus t. This was 5 to the power of t squared plus 4t. So it was really close aside from that 4. So it ended up being not equivalent, but we did have to check.
We just all had to check.
I know.
3 times. No. Oh my goodness.
My head hurts.
The thing is, this entire unit builds off of this one
Oh,
lesson.
this?
Yes, so you have to know this one lesson to do the rest of the lessons.
I think I'm gonna cry now.
Again, we have 1 day of leeway in our schedule. I can extend this lesson to 2 days, but it means everything else, we have to do it 1 lesson per day.
This is the hardest lesson in the unit.
It's pretty hard.
Not in the unit though.
It's not in the unit, though.
Oh.
Wait, this is not.
This is welcome to Algebra 2.
Oh.
Can I see the rest of it? So I can joke that later.
All right, so 4xp. Let me give Andrea her xp. 4xp, is it equivalent or not equivalent?
Yes.
Not-
it's equivalent. I don't
No,
It's not.
no.
Compare this to this.
It's not.
It's not.
Woo!
Because it was a 4t versus a normal 1t. All right. Now I'm going to be using these rules of exponents here. I'm going to be using these 2 rules. When I multiply, I add the exponents. When I divide, I subtract the exponents. I'm going to do that all at the same time. This is now going to be 5 to the power of
4.
t squared, then what?
Wait, what? Oh.
5, 9.
What am I going to do with this 7t?
You added.
I added. Exactly. This was multiplication, so I'm going to add t squared and 7t. I'm adding the exponents. So far, so good?
Yeah.
So 5t squared plus 7t, then what?
Minus 3.
Minus 3t. And simplify. That's going to be 5t squared
Plus 14.
plus 4t. Hey, check that out.
Wow.
Look at that form. Look at that form. These are equivalent. Ask me questions. Okay. I kind of am getting annoyed too because T's and pluses are getting mixed up.
Yeah, the next time you like choose
I will remember to not use T's anymore. All right, I need someone to help me with my final expression. You're doing that same thing over and over. It is going to be equivalent, Gio's saying. Gio is correct, but I need someone to explain why.
Because you do the same thing, the 25 blah 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 thing, and then you get the same answer.
Oh yeah.
So 5t squared, nothing has changed for the 5t squared.
No.
Gio has told us I do the same thing, so I'm going to multiply by, this 25 turns into a
5 squared times 2, yeah, whatever.
to the power of 2t. 2 times 2t is 4t, and then I add the 4t with the t squared plus 4t, which is exactly what matches up with our original problem.
Wait, hold up, what happened to
What was
the
the
5?
original problem? 25, 0,
The original was 5t squared times 25t, and then like turned it into.
This was the original, which turned into this original right here.
And then you have to make sure that when
Alright, cool. Next page.
no.
Do we want to use that one chip on today? Remember, you had that one chip for all of Unit 7 and all of Unit 8. No? We're going to push through?
How's Unit 8?
Unit 8 is, I'm pretty sure Unit 8 will be easy. I know how to teach logarithms really, really well.
Oh,
Logarithms.
So
Logarithms.
if you use the whatever, so we're stopping right here now.
We can stop right here now, but it means that we cannot miss a single day. If there's ever a day that you are not here, we have to just push on through.
Alright, let's stop it.
We're going to stop it. We're going to call it.
No!
No, we have to keep going.
We'll push on through. Example 3.
Wait, can you go back up?
Flip over to the back.
No, let's play rock, paper, scissors.
Yeah.
I want to stop.
Okay.
I want to stop right now.
That's just you.
Hey, what are you, the king?
Alright, let's play rock, paper, scissors. If I win, we're stopped.
Majority
Yeah.
rules. Raise your hand if you want to continue on. If you want to pursue and continue and persevere.
I don't understand.
All right, the majority of the class wants to persevere on to example
Rock,
3.
paper, scissors, right?
I'm sorry, Gio. Majority wins. Welcome to a horrible way to elect people. All right, plurality. I need to rewrite this. This is. Can we do example 3 at the very end? It's the hardest one out of this whole
No, let's do
lesson.
it right now. No, let's do it right now. I want to do it
No,
right now.
no,
No, I want to do it right now, bro.
Let's do example 4.
I want to do it.
Let's do example 4. This one is a little bit easier. I need to write this as 5 to the power of something. I need to figure out what that something is. What is that something? So I need to rewrite this with 5. It's the same process again. 25 can be rewritten as something with 5. There it is, 5 squared. So I'm rewriting that 25 as 5 squared. And I'm going to rewrite the rest of the exponent, negative 3x plus 5. I do the same thing for the bottom. The bottom can be rewritten with a base of 5. Base of 5 to what power gives you 125? And it's not on the wall, sadly. It is to the third. 5 to the power of 3, and if you don't trust Mr. Sandell, trust the calculator, 5 to the power of 3 is indeed 125. But this 5 to the power of 3, which is 125, is still missing the exponent of x, so there it is. I have rewritten my fraction using only base 5s. So far, so good. That's kind of a review of what we've been doing for those medium level problems, right? Now we're going to apply rules on that where we multiply these together. 3 times x is 3x. So this is now going to turn into, on the bottom, 5 to the power of 3x.
How are you going to 3x?
Someone else answer it.
Oh, there's the 3. Never mind. Sorry. Alright, cool.
Oh yeah, you're good. All right, the harder part that I want someone else to answer is, what do I write for the top? Gio's been participating a lot. I want to try to give it to someone new, build their confidence. Stego?
5. If I get this wrong, I'm sorry. 5, negative 6x.
So far, so good.
Plus 10.
You got it. There it is. Yes, you multiply the 2 and distribute the 2 into each of these terms. You always, always, always distribute. Always. And we're almost there. We're basically there. Now I need to do that thing that says if I divide similar bases, I do what with the
You
powers?
subtract it.
You subtract it, and you get what, Gio?
5 to the power of negative 3x plus 10.
That's
Dude, I don't
Nine
care,
X,
alright.
negative 9x.
I don't want to do
Negative
this.
plus 10.
Oh yeah, that's true. I'm gonna use this one.
So here's our answer. Box it.
Dude, I hate this class. Sorry.
That's our answer?
That's our answer. Because we needed to rewrite it as 5 to some power. It's asking, what is that power? The power is negative 9x plus 10. Done. Okay, well, that makes me happy. You want to try 3?
Yeah,
3 will shatter our confidence, and then 5 will build our confidence back up.
Oh, I like that.
All right, here we go. Example 3. We need to write this as some number times 2 to the power of x. So we need to get a 2 to the power of x factored out of everything else. And that's hard because we have not seen it before. I haven't even seen it for like 3 years. I've never seen this for a long time. Factoring out a 2x, a 2 to the power of x, if I'm saying it correctly. When I factor out a 2 to the power of x, what is left over?
What?
So I want to go backwards when I add powers. When I add powers, going backwards to get two things that are multiplied by each other.
So 2x parentheses. Oh, never mind.
2 to the power of x times what, Gio?
3.
There it is. 2 to the power of x times 2 to the power of 3. We're doing this rule right here. No, there it is. We're doing this rule right here backwards. We started here and we ended here. Come back and take another look at it. We started with them added and we're going backwards to make it multiplied with the same bases. And then finally subtract 2x, 2 to the power of x. So far so good. All we did was we went backwards by a step. Now we're going to factor out a 2 to the power of x. You guys have done a whole unit on factoring, a whole unit on using factoring with rational numbers. I'm going to factor out a 2 to the power of x. What two numbers here and here are left over after I take away a 2 to the power of x? I'm dividing this term by 2 to the power of x and dividing this term by 2 to the power of x. I need to know what is left over. James. Not quite. So if I take away the 2 to the power of x on this one, I'm left over with Andrea, go for it.
2 to the power of 3.
2 to the power of 3. So if I take away 2 to the power of x, what's left over is 2 to the power of 3. You're really dividing by 2 to the power of x. When I divide 2 to the power of x divided by 2 to the power of x, dividing the same thing by the same thing, you get, Fiona? Negative 1. And yeah, don't forget that negative out front. It's a negative 1.
Okay.
Okay, this is
Question? You got the answer? Oh, what are you doing?
I'm just there.
Oh, you're just there? Whew. All right, nice. All right, I'm going to simplify this because look, we're done. We're done. This is a. This is 2 to the power of x. This is a. This is 2 to the power of x. We are done.
Wait till you're 8.
We just need to simplify this a, and we're done. Ready? 2 to the power of 3.
8.
8.
Oh,
8 minus 1.
What are you waiting for?
7.
Oh.
This is 7 times 2 to the power of x. A must be 7.
Can you do that one more time?
Yes. So what we did, we started here and we said, oh, if you're adding powers, that means when we break them apart, you're really multiplying the bases. So we multiply the bases, 2 to the power of x times 2 to the power of 3. Nod our heads.
Yeah.
From there, we factored out a 2 to the power of x. I divided this thing by 2 to the power of x, and 2 to the power of x was eliminated to get 2 to the power of 3. I divided 2 to the power of x divided by 2 to the power of x to get 1, but also this minus sign here. So I factored out 2 to the power of x. From there, I need to rewrite what 2 to the power of 3 minus 1 is. 2 to the power of 3 is 2 times 2 times 2, 8. 8 minus 1, 7. The answer is 7. All right, and on to example 5. I will be honest with you. I missed this one 2 times in a row before I got it correct. So if you get this wrong, do not feel bad.
It's 8, bro.
If we get it right, can we get a grade bump?
The main thing here, whenever you have something set equal to a, where a has a number with the x, you need to get rid of that number, Julian. I need to get rid of that -7. What I can do to both sides is I can take both sides to the power of -1/7. This side to the power of -1/7. That will get rid of that number. You want just a to the power of x. This is infuriating because there's a number in front of that x. Get rid of it. The only way to do that is to take it to the power of the inverse operation. The inverse of -7 is or it's technically -7 times x. The inverse of that is divide by 7, which is the same thing as multiplying by the fraction with 7 in the denominator. What that does is it crosses off the 7 and crosses off the 7, and I'm left with a to the power of x on the right. Really digest this. This is a key rule in mathematics where I cancel things out. It's that higher level now. How do I cancel out things that have powers with them? I take it to a power.
And the only reason you cancel it out is because you want a by itself.
I want a to the power of x by itself, yes.
Oh, why not just x?
Why not just a? Well, we can't do that until we hit logarithms because x is trapped in the power. The only way to get x's untrapped from a power is to use a logarithm. That doesn't happen until unit 8. These, in many ways, are harder because you are fighting with one hand behind your back. You don't have logarithms. Once you have logarithms, these are super easy. Dual wield, wield a shield, I don't know. So what I have now, the thing is, logarithms go backwards from exponents. So I have to teach you how to do exponents, which are going forward, before I teach you to go backwards. When you are a baby, unless you're a weird child like my child, you learn to walk forwards and then backwards. I'm teaching you to walk forwards, and then logarithms will be teaching you how to go backwards. That's why I teach logarithms second, and why most people teach it second. So what I have on the left-hand side now is I have multiplying this -1/7 times x. So I have 1/5 to the power of -1/7 x. I need to now turn this a into something that matches this part. This needs to be a. That is a. That's it. We're done.
What?
Wow, that's it.
That's a. Look, this is a to the power of x on the right-hand side. We nod our heads. We canceled out that -7. If that is a to the power of x, notice that this box and this box are matching, and then you have a leftover power of x, power of x.
You
Nice.
got this wrong twice in a row?
I know. I feel sad.
Stego.
Everyone makes mistakes. Take that away from that too. All right, so what is the answer?
B.
B. I don't know why Mr. Sindel kept putting D twice, but it is B.
I guess. Alright,
I quit.
This is A.
Now, can I go talk to Miss G?
Yeah, Miss Sasson. All right, ask me questions now. You have Mr. Sindel for the rest of class. Ask me questions.
Can I not do this?
No, you have to do it.